In science, we have different ways of explaining the world around us. We use different categories of ideas to distinguish what they are actually trying to be used for. So one of these categories is a scientific law. A scientific law states what you are going to see when you are performing some observation. So a good example would be like Newton's third law of motion, that every action has an equal and opposite reaction. So you throw a basketball against the ground, it exerts force against the ground, and the ground exerts force back, pushing it backwards. This doesn't explain why it takes place, it just explains that it does, it always will, and that is what you're going to see. A scientific theory, on the other hand, explains why we see what we do. And so a theory is heavily supported by evidence, observation, and experimentation, and is not actually the same as the way that the rest of society uses the word theory. Society uses the word theory to mean guess or hypothesis, whereas in science, it is actually a proven idea based on the information we have collected so far. In chemistry, one of the major theories that we use to help us explain chemical reactions is called collision theory, which is actually like a pretty common sense theory that in order for molecules to undergo chemical change, they have to collide with each other. When they have to collide at the right angle and with the right energy. And if those things don't happen, then the reaction doesn't happen. They bounce off each other and continue on their way. They will continue to collide, and the more times they collide, the better chance that they actually will undergo that chemical reaction. Now, this also means a few other things. For some chemical reactions, it means that in order for it to take place, it actually has to happen in a series of steps, which is what we call a reaction mechanism. So let's take a look at this example of a reaction. We have two nitrogen monoxides reacting with oxygen to produce two nitrogen dioxides. Keep in mind, oxygen is diatomic. It's one of the elements that exists as two of that atom stuck together. Now, if this reaction was going to take place, it means that you would have to have two nitrogen monoxides colliding at the exact same moment as one oxygen, all hitting at the exact right angle with the exact right energy. For that to take place is pretty rare. It's probably not actually going to happen that way. And so instead, we use what we call a reaction mechanism to describe how the reaction was going to take place. A reaction mechanism breaks a reaction down into a series of steps. Each of those steps will then add up to produce our overall reaction. So in step one of this reaction mechanism, to explain what's happening here, what's going to take place is two of the nitrogen monoxides are going to collide with each other at the right angle with the right energy. And that's going to produce this substance, N2O2. That's our very first step. And that's all that's going to take place in the first step is two of those collide, they react and form this thing. But then immediately, step two is going to take place. And in step two, that substance that we just formed, N2O2, is going to collide with a molecule of oxygen and break apart into two NO2s. Now, this is a much more likely scenario than having this all happen in one step. To have three things collide with the right energy and the right angle versus having two separate collisions making something along the way that disappears is probably much more likely. Now, one thing I mentioned is that you can actually add this entire equation up, add up each step to get the overall reaction. And for every reaction mechanism, you should be able to do this. To do this, you just need to take a look at everything that's on the left-hand side and everything that's on the right-hand side and pull them down on the left and right-hand side of the arrows. The only thing is any substance that is both a product and a reactant must be canceled out. This substance here, the N2O2, is a substance that was made at the end of the first step and disappeared at the start of the second step. So that means we are actually going to essentially cancel it out, cross it out, and not include it in my final overall reaction. So all that's left is 2NO2 plus O2, both as gases, and 2 NO2s as our product. You see that the overall reaction that we added this up to be is exactly the same as the overall reaction when we started. This substance that we produced partway through is called the reaction intermediate. A reaction intermediate is the substance that gets formed but then is used up before the reaction is over. It is produced intermediately but is not a part of the overall reaction. So when it comes to using a reaction mechanism, really it's just about analyzing the steps, adding them up, and finding your reaction intermediates and making sure you cancel them out before you get to your final reaction. At a high school level, it is not expected that you will ever have to create your own reaction mechanism. That's just too difficult, and there's way too much that goes into actually figuring that out. Really, what you should expect is how to analyze one and be able to come up with an answer from it. So thanks for watching, and there will be another example video after this, so if you need a little bit of extra practice, feel free to check that out. Thanks for watching.